if you don't want to split the power into two, if you want to split it unequally, that means you don't want to half, but you want to get, let's say, 1/10 here and the other 9 parts to the other side. Then you can use the device that we're going to see, which is called as a directional coupler. In the directional coupler, if you have in port 1, you feed a signal in, a part of the signal goes to port 4, which is called as the coupled port, and 1 minus k square p goes to the isolated port. So the power that gets separated is rather small. That means what goes here might be much larger than what goes through, which is defined by the so-called coupling coefficient, which determines K determines the factor of how much of this power goes in here, how much of the power goes in here. For example, if you just want a 20 dB directional coupler, then K equal to 0.1. That means the power that gets coupled in the coupled port that I get at port 4 is going to be just 1%, 0.1 times the input power. Whereas the 99% rest of it goes into port 2. So this is the ideal S parameters for a directional coupler, where this is the coupled port. Rest of the power flows in here. Port 3 should be the isolated port. This guy is the isolated port. This is the coupled port. That means what you feed here, nothing goes here. Part of it goes here, part of it goes there. This is completely isolated. A directional coupler is what is used inside a VNA because we want to know, let's say you want to measure a 2-port device. You want to know what is A1 and what is B1, right? So you can't simply connect the source to P2. You want to know what you are feeding in. So inside there will be a so-called directional coupler that will know maybe 0.1% of what is sent in is coming back, and you know what you're sending in, so that the rest of it goes here. So a directional coupler is an essential component in a vector network analyzer, a VNA.